2.7 and 2.8 are about derivative of a function. So you have a function fx, right? The derivative is essentially the slope of the tangent line. So let me draw this function, right? The function, say, look like this. And at this point, I call this A, the tangent line is essentially the line that goes through this point and only touch the curve at one point, like that, right? So they only intersect at one single point at A. So this is the tangent line. And the slope of this tangent line is called the derivative at this point. Okay, and this the slope m, we know is going to be a limit. Okay, it's when x is becoming closer and closer to a, fx minus fa over x minus a. So once you know fx, you just plug in fx here, and then plug in your a to get fa. Then denominator is x minus a. Then you try to simplify that. Or you can do the other method. It's h goes to 0, fx plus h minus fx over h. The same idea. That means you take 2 points. One is right here. Another point is on the curve, but very close to this point, to the first point. Okay, and you just simply calculate the derivative of this line, and if x gets closer and closer to a, this is the slope of the tangent line. Right? So you can have, if you know this f function, you can just plug in f and then try to simplify this. So let's say we have fx, right, which is 3 over x. This is your function. And we have a point on this curve, 3, 1, right? Because if x equals 3, y equals 1. So this point is on the curve. And we want to know the derivative of the function at this point, or the slope of the tangent line at this point. So we can do m, right? It's limit h goes to 0. I like the second formula, but the first one and the second one, so these two are totally equivalent. Okay, my personal taste is to use the second one. So it's h goes to 0, right? F x plus h minus fx over h. And since fx is 3 over x, so that will be 3 over x plus h minus 3 over x divided by h. Okay, so this is x plus h, fx plus h. This is fx. Now the rest will be just try to manipulate this function, simplify that, to those trig things. And what we can do is we can multiply by, so let's write this and multiply by x and x plus h, both on the top and on the bottom. Because we want to get rid of the quotient, right? We don't like quotient. Quotient will make things complicated. So on the top, you will have 3 times x minus 3 times x plus h. And then this one. All right, try that. And on the top, you can cancel. So they have 3x minus 3x minus 3h. And these two cancel. You have negative 3h on the top. Something like that. right? So h will cancel. And you have -3 and x times x plus h. And h goes to 0. So you can see that you still have -3 on the top. On the bottom, you have x times x plus h, but h goes to 0. So it's just like x times x. You have x squared. Right? So this is the slope of the tangent line at any point on the curve. And we want to find the slope at 3, 1. Right? So x equals 3. Now what you can do is plug in 3. So if you do that, it will be -3 over 3 squared. That's -1/3. All right? So that's the slope of the tangent line. Now, if you want to have the equation for the tangent line, right? Because what you have is you have a point, which is right here. You have the slope. So you can use a point slope formula, right? So what you do is y minus 1 equals -1/3 x minus 3. Because the slope is -1/3, right? And this point goes through 3, 1. So 3 will be this one, and this one is that one. Okay, this is how you find the derivative or slope of a given function. For velocity, it's just exactly the same thing, right? You have instead of have f, you have a position function, and the velocity is the derivative of the position function. So that's 2.7. Now for 2.8, it's still about derivative of the function. Okay, there are more examples, and one thing you can try is something like, if you have a function, okay, just draw any function. Say the function that goes like that. Right? Remember, derivative is essentially the steepness of the function. Okay, is your function very flat, or is changing, or is like increasing rapidly? Okay, so the slope can give you the derivative, and you can see that from just by looking at the function. You can get some sketch of the derivative. Okay, so in that case, what we have here in the beginning, right here, if you look at this part, the derivative should be positive because you have this increasing trend, right? The function is getting bigger and bigger, so the derivative is positive, and then it get the increasing is getting slower and slower because you get this bends down, right? So it's positive, but become lower and lower. Now at this point, it's flat, right? The trend is going like from left to right. So at this point, the slope is equal to 0. So it will get something like this. Originally, it's going to be a big number. Then it gets lower. Then lower and lower. At this point, here is equal to 0. All right. Now after that, the function, this curve here goes down. That means the slope is negative, right? The slope is going downwards. So it's become negative, and then it becomes more and more negative. Originally, at this point, right, it's still very close to 0. The decreasing is very slow, but it becomes faster and faster, and then at some point, the decreasing will be at its maximum. And after that, the decreasing will become slower and slower. So what you get is something like this. Okay, at this point here, the slope becomes 0 again, and this is this b value. And after this, the decreasing is getting faster and faster. Okay. So, yeah, I mean, it's just a sketch, so I don't really think this is a very good plot. Actually, I think the plot should be like that. Okay, at A the slope is 0, B slope is 0, so maybe it should be something like that. Okay. Now it's gonna look like this. So this is the important thing. All right. So that's something about derivative and the slope. I think you could, just try more examples from 2.7, 2.8. I think that should be good.